Good morning. Myself Prabharanji, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic is linear phase FIR filter from the unit 3, that is FIR filter design from the subject name is digital signal processing. Let us discuss. Yeah, already we have discussed what is mean by IIR filter. IIR filter and FIR filter comes under the digital filters. FIR filter is nothing but this is non-recursive type filter, and also finite sample of impulse response is needed for FIR filter design, whereas IIR filter we need only infinite number of samples. This is the main difference between FIR and IIR filter design. Also, the transfer function h of z of the digital filter is obtained by taking z transform of impulse response. Since h d of n, which means desired impulse response, h d of n is an infinite duration signal. The transfer function obtained from the h d of n infinite time, which cannot be realized of the implement in digital system. Therefore, finite number of samples multiple with infinite number of samples. So we are using windowing technique in this. We are using windowing technique for this FIR filter design. And here you can see, let me discuss the advantages and disadvantages of the filter. FIR filter with exactly linear phase can be easily designed, and also efficient relations of FIR filter exist as both recursive and non-recursive structures. FIR filter realized non-recursively by direct convolution are always stable. Also, the disadvantages, the duration of impulse response should be larger to adequately approximate sharp cutoff filter. Hence, a large amount of processing is required for realize such filters when realized via slow convolution. So it leads to latency. Okay. Uh, Let me see what are the steps involved in the FIR filter design. First step, we have to choose correct or perfect HD of desired frequency response for a designed for a going to design which type of FIR filter, which means low pass filter or either high pass filter, whatever may be, band pass filter, band stop filter. Choose first step, choose an ideal frequency of frequency response, which is represented by capital H and small d into E of j omega. Second step, how to take inverse Fourier transform to get HD of n. The HD of n signal duration is minus infinite to plus infinite. To convert this infinite to finite, we have to multiple with this infinite sample to windows, which means we are using windows. This windows has finite number of samples, which will multiply with this HD of n. Also, the frequency response h e power j omega, the magnitude response and phase response. Magnitude response is magnitude of h e of j omega. Phase response, phase of h e power j omega. Also, this FIR filter have two types. First one is linear phase FIR filter. Another one is non-linear phase FIR filter. For symmetric FIR filter, theta is nothing but the minus alpha omega, and both phase delay and group delay is constant in symmetric FIR filter. This is the ideal frequency network. For designing, we should know about this limit of the filter. For example, for low pass filter, hd of e power j omega, that is frequency response, which is equal to 0 for minus pi to minus omega c and plus omega c to plus pi, and have one value, which means magnitude 1, and phase response is e power minus j omega, e power minus j alpha omega, because theta equal to minus j omega. Okay, for omega equal minus omega c to plus omega c, whereas for high pass filter, magnitude value 1 for omega equal to minus pi to minus omega c, and omega equal to plus omega c to plus pi, and 0 for minus omega c to plus omega c for high pass filter. This is the idea. Similarly, for band pass filter, this is the limit, and band stop filter, this is the limit. Okay, well, this is the low pass filter, minus omega c to plus omega c. The magnitude value is 1, otherwise 0. For high pass filter, minus pi to minus omega c value is 1, and my omega c to plus pi value is magnitude value is 1, otherwise the signal is 0. Same as similarly it is for band pass filter and band stop filter. This is the magnitude response, and pass band ripples. You can see pass band ripples. This is the stop band ripple. Magnitude response. Okay, alpha p is nothing but the del p is nothing but the pass band ripple, del s is nothing but the stop band ripple, omega p is pass band frequency, and omega s is stop band frequency. This is the formula for Fourier transform. H e power j omega equal to summation n equal to 0 to n minus 1 h of n into e power minus j omega n. And some of the magnitude response and phase response, you can see the formula for this magnitude response and phase response. This is the first have to know about the what are the limits for ideal filters, which means ideal low pass filter, ideal high pass filter, band pass filter, band limit filter. We should know about that limits of that filter. From that we can derive the hd of e power j omega, and second step is to take inverse Fourier transform to get the hd of n with infinite limit. For converting the infinite to finite, we have to use windowing technique, which is multiple with hd of n. And also another step is to find the magnitude response, and we have one formula already we have discussed. Find the magnitude response and plot the filters. This is the assessment for this lecture. Define FIR systems, finite impulse response filter systems. Mention the advantage and disadvantages of FIR filter over the IIR filter based on the based on the frequency response of the filter. How it classified into four types. What are the steps involved in designing FIR filter? These all are the assessment of this video lecture. If you have any doubt about this video lecture, you can comment me. You can ask me through the comment. Okay. Thank you. We will meet in next video lecture. Thank you.